So this problem is another example in the moment distribution method. This is sway problem. So frame with a different column length subjected to 100 kilonewton horizontal loading. There is no load on the span, and the moment of inertia is different for a beam. It is 2 times of I. For the column, it is I. So before going to the problem, we recollect the steps, the overall steps. First one, non-sway analysis, and it's a horizontal reaction H. Third one, sway analysis, and H dash. Fifth one, the correction factor R equal to H by H dash. Sixth one, the final momentum. Final momentum means non-sway analysis moment plus correction factor into sway moment. So you have to keep these overall steps in your mind. Then coming to this problem, you should know the support condition, simply supported condition at the D position. A is fixed while you calculating the distribution factor. You have to keep in mind far end fixed is I by L, and far end is simply supported, it is 3 by 4 I by L. So first one, distribution factor, joint member K, summation of K, and then distribution factor. The inner joint B and C is considered. It comprising of BA, BC, the member, and the corresponding stiffness value. When far end is fixed from B to A, it is I by L. So it is I by 4. Far end is rigid because it is an interior joint. So it is also considered to be rigid. So it is also I by L, but I is 2 times of I. It is given in the problem. So totally 3I by 4. So if you divide the relative stiffness to the overall stiffness, you will get 1 by 3. If you deduct 1 minus 1 by 3, you will get 2 by 3 for the other member. Anyhow, let us check. 2I by 4 divided by 3I by 4. If you cancel 4 and 4, I and I, you will get 2 by 3. For the members, for the joint C includes C2B and C2D. Where C2B, it is an interior joint, so it is considered to be fixed. So I by L, I is 2 times of I. So 2I by 4. When far end is hinged, it is 3 by 4 I by L. L is 4.5. So if you calculate the summation of K, you will get 2.67 I, and individual stiffness you will get 2I by 4 divided by 2.67 I, which is equal to 0.75. Here it is 0.25. 1 minus 0.75 is equal to 0.25. You will check the answer by calculating into 4.5 divided by 2.67. So we have calculated the distribution factor. Next one, for the sway condition, the column member A to B, you apply a horizontal force so that it will deflect like this, and the direction of moment is anti-clockwise. It is created due to this horizontal sway. Similarly, for the next is AB column. Here it is CD column, where D is hinged support, where moment is 0. It is also subjected to a horizontal sway, and a moment is created at the top only, because bottom the moment is 0, and For support settlement problems, we know that delta amount settles, then the moment created is 6EI del by L square, where the for both the ends are fixed. If it is one end fixed, other end is hinged, then the moment created is 3EI by delta by L square. So in this case, we have to consider 3EI delta by L square. Here 6EI delta by L square on both bottom and the top. So it is a very important concept you have to remember. When far end is hinged, the moment is 0 at the hinge point. At the opposite end, 3EI del by L square is the moment value. When both end is fixed, 6EI del by L square is the moment value. So in this condition, we know the moment value. So it is 6EA, it is 3EA. 6EI del by L1 square. Here 3EI del by L2 square. So MBA equal to 6 minus, because of anticlockwise, you continuously follow the sign convention minus throughout the problem. You should not cancel the minus at top and bottom. So L1 square, and for MC to D, it is minus 3EI del by L2 square. If you divide, you will get 2 minus 2 EI del by L1 square divided by minus EI del by L2 square. You can even cancel that and n smallness. If I differs, you have to consider I. So now MBA is at the top and MAB is at the bottom. So we consider MAB equal to MBA here. Both are 6EI del by L1 square. Here only 3EI del by L2 square is available. Here moment is equal to 0 because of the hinged support. So we simplify this MBA divided by MCD, which is equal to minus 2 into I is both the column it is I, both the column it is I, so consider it is I only. So I by L1 square is 4 square divided by minus I divided by L2 square is 4.5 square. So if you reverse the formula, it is 4.5 square by 1. So you will get minus 40. So you should continuously bring this sign throughout the problem. You should not cancel the minus. Minus 40.5 divided by 60. So for the sway analysis, you have to consider the fixed end moment for MBA, which is equal to MAB, which is equal to minus 40.5 kilonewton meter, and MCD bar equal to minus 16 kilonewton meter, and MDC bar equal to 0 because of the hinged support. So next one, we can continue the sway analysis. Because of there is no load in the spans of beam as well as column, the problem is contains only the load at the joint. For the calculating of fixed end moment for non-sway analysis, we need the loading in the middle or throughout the span of the members, but we have only one load and also it is acting on the joint. So there is no way of calculating fixed end moment. So there is no need to analyze the non-sway frame. So directly we can go to sway analysis. Sway analysis. So joint member distribution factor fixed end moment. Joint A, B, C and D, member AB, BA, BC, CB, CD and DC. Distribution factor we have calculated as 0.33 for BA, 0.67, 0.75, 0.25. So we can make a table for our convenience. Distribution factor and the fixed end moment value for AB and BA is minus 40.5. We have calculated as minus 40.5, minus 40.5, and for CD it is minus 16, for DC it is 0. Why it is 0? Because of the hinged support. It is 0. Here it is minus 38 L by L square. Here it is minus 68 L by L square. At the bottom also minus 68 L by L square. So now you consider the joint equilibrium and balance B with the plus 40.5 and C with plus 60 because it is minus 16. The summation of moment at the joint equal to 0. So for the equilibrium condition, we need plus 16. You multiply it with the corresponding distribution factor 40.5 into 0.33. So it is 13.37. 13.37. Next one 27.14. Okay. Next one 12 and 4. Okay. Now consider the distribution carry over. Where it is carry over to the nearest joint. So from B to A is to be half of the moment to be carried over, B to C half of the moment to be carried over, and C to B half of the moment is to be carried over. C to D we should not carry over the moment from C to D because of the hinged support. I am repeatedly telling for the hinged end we should not carry over the moment. So you carry over. So the next step is carry over and intermediate carry over. So it is 6. Here it is 13.57 and 6.685. So finally you add for the first iteration. Okay, you can write bending moment for the first iteration. So you add from fixed end moment to this value. So it is minus 33.815, minus 27.13, 33.14, and 25.57 and minus 12. Again, you try to balance B with the value minus 6. C with the value minus 13.57 and you multiply it with the corresponding distribution factor and 1 minus 1.98 minus 4.03 minus 10.18 minus 3.39 and carry over to the nearest joint fixed joint only, and intermediate carryover as minus 2.015 minus 5.09. Again, we calculate for the second trial. So we have completed the second trial. Bending moment 2. You get minus 34.805 minus 29.11, 24.02, and 13.375 minus 15.39. Here the 0 exists throughout the next balance B, the moment of 5.09, and C with a moment of 2.01, unbalanced moment. And you multiply with this distribution factor 1.68, 3.41, 1.511, and 0.50. Okay, then you carry over this moment as 0.84, and here 1.705, and this one 0.7555, and again you add another one iteration is remaining. You get BM3. For the trial 3, you will get the value minus 33.965 minus 27.43, 28.18, 16.59 minus 14.89. So here you can put C. Again, balance B for the moment of minus 0.75, C for the moment of minus 1.7, and you multiply with the distribution factor, then it is minus 0.25, minus 0.5, minus 1.28, minus 0.43, and you carry over this value minus 0.25, here it is minus 0.64, and then minus 0.125. Again, finally, after this, okay, you can add this value now. Minus 34.09, minus 20, minus 27.68, and 27.04, 15, and minus 15.321, and 0. So this is the moment finally. Okay. Now we have to calculate H and H dash. So we get the sway moment NAB equal to minus 34.09 kilonewton meter. MBA is minus 27.68. MBC 27.04 kilonewton meter. And MCB equal to 15 kilonewton meter. MCD equal to minus 15.321 kilonewton meter. MDC equal to 0. So these are all the sway moments. Sway moments. Okay, now we draw the column AB and mark the moment. Both the moment values are anti-clockwise. So mark this anti-clockwise, and you can be able to judge the direction upward for this type of moment HA, and downward for this type of anti-clockwise moment HB. Okay, the length is 4 meter, and also consider the horizontal load of 100 kilonewton. And taking moment about, so you can mention this dash because of the sway analysis. moment about B equal to 0. So HA dash into 4, the value here is 34.09 and 27.68 minus HA dash into 4 minus 34.09 minus 27.68 equal to 0, where HA dash equal to 15.25 kilonewton. In the same manner, for the column D and C, where D equal to 0 moment, M equal to 0, here we have anticlockwise. So with this, you can judge H C dash in this direction and H D dash in this opposite direction. So the length is 4.5 and taking moment about C equal to 0. So H D dash into 4.5 minus the value here is 15.32. So minus 15.32. So here minus 15.32, then I put anti-clockwise direction. So I compared the rotation. HD dash is rotating like this. HD dash is rotating like this, and uh, moment at C is rotating in the opposite direction. That's why I'm putting minus equal to 0. So HD dash equal to 3.40. So now consider uh, the direction HA dash and HD dash. So H equal to HA dash plus HD dash. So if you assume an opposite resultant of H dash, then only you can write this equation. So by considering towards right is positive, H dash minus HA dash minus HD dash equal to 0, then only you can get H dash equal to HA dash plus HD dash. So the applied load, here it is HA dash and HD dash are the internal components, so which are created internally for the externally applied load. So the load will be in this direction, so that the reaction will be in the opposite direction. So H dash equal to HA dash plus HD dash equal to 15.25 plus 3.40, so totally 18.65 kilometers. So this is all about sway analysis. So in non-sway analysis, you can observe that a 100 kilonewton load is acting, so that HA will be towards this direction and HD also towards this direction, because there is no other load to alter the direction. Because of the rightward of 100 kilonewton, definitely the reactions will be towards left. So the H is also in the same direction of H dash. So H is equal to 100 kilonewton. H dash is equal to 18.65. So correction factor R equal to H by H dash. So 100 by 18.65, which is the correction factor. Here it is 5.36. 5.36. So finally we coming to the end of this problem. So first of all, take member, non-sway moment, and sway moment. You can add correction factor and final moment. So I am giving very small representation. You have to write elaborately as member, non-sway moment, and sway moment and correction factor is not in abbreviated manner. You should write elaborately. Okay. Final moment. Okay, and first mention the numbers AB, DA, DC, CD, CD, and DC. Non-sway moment, because of There is no external load in any of the span. Again, I am repeating, the load should be on the span of the member. Then only we can calculate using WL square by 12, WL by 8, WAB square by L square. So there is no load on the span. So one half of the procedure is not needed. Next one, sway moment, we have already calculated minus 34.09, minus 27.68, 27.04 and 15, minus 15.32 and 0. Correction factor is all same for all members. So we can add on this column. Here also, you just multiply the sway moment with the correction factor because the formula is non-sway moment plus correction factor into sway moment, which is equal to final moment. So here non-sway moment is 0. So directly you multiply with the correction factor. So final moment is from 82.72 minus 144.72 plus 144.72 and 80.4 minus 80.4. So these are the final moment value in kilonewton. So you have to mention the unit also in kilonewton. So with this, we have finished the sway analysis of the given